Continuing from the previous video, I was talking about how existence isn't just one scale, but it's actually divided up into 30 scales. And each scale has 3 parts, and these scales come in pairs. And then these pairs are grouped into 3 pairs, which become the 3 parts of a hyperscale. And you can see that a hyperscale is analogous to a scale. So there's not simply, well, let me give you an example. So we have like abdomen, thorax, and head. And so you could see that the 2 parts, like saying a beetle or a bee, is easiest to see this. Whereas the back part, which is usually bigger, and it's a combination of units, then the thorax is a combination of units, but it's much smaller. And then there's something that we call a head that seems like a big unit. But in one sense, the thorax, or the abdomen and the thorax are grouped by kind, in that they're different than the head, but also the thorax and the head are grouped in size relative to the abdomen. So the point is that they have 2 and 1 parts, but also 1 and 2 parts. It's not excluding, it's using both kinds of grouping, and we'll get to why that is at some other point. But so that scale, there's the next scale down that it makes a pair with is organ system, organ, and tissue, and it has the same kind of motif where it's got like 2 combinations of units and then a unit. But the organ and the tissue are more closely related than the whole system. And then that's a pair of scales, and then it jumps down a pair of scales, and you have the outer cell, the nucleus, and the nucleolus, which is like a huge molecule. And he's saying that have that same motif of like combination of units, and unit. Now, some of these scales are hierarchical, and some of them are linear, but they still have the 3 parts to them. The next scale down is, okay, the folded tertiary protein also has appendages to it that are added on after the fact, after the folding of the protein, and then it's combined. That's the first part. Then that's combined into a quaternary structure, which is a combination of tertiary proteins, and that's part of a network, a functional network, this cell. And you can see how that's analogous to the organ system, organ, tissue motif, just one pair of scales down. And then the next pair of scales down, you have the primary, secondary, and tertiary folding of the protein. And then you have, next scale down, you have the exon, gene, and then the promoter sites for the activation of the transcription of the protein. So what's interesting here is, say, like primary, secondary, and tertiary folds of a protein, and the exon, gene, promoter sites. Well, you can see how that's kind of analogous to like adverb, adjective, noun, and syllable, word, and the context. It'd be sort of analogous to promoter sites for this meaning rather than some other meaning of a word. So that's important because there's another set of scales that make up part of the mind that are exactly analogous to what I'm talking about, just in terms of biology, where even a sentence is one of these scales, and one of these kinds of sentences is a noun phrase, verb phrase, explanation phrase, or because phrase. So like you'd say like A is B because of C, and then those are divided up into prepositional phrases. Anyway, I don't want to get off track. So if you keep on going down, you get like codon, which you see the three bases, and then the base itself has a phosphate and it has these like two ring-like structures, and it has the same motif. Then the atom, you have the doublet, the nucleus, and then the outer shells, and then you have the N, L, and M quantum numbers, and then you have a baryon, which is 3 quarks, right? And then at the bottom you have mass, charge, and spin. And what I just described to you is basically 12 scales broken into 2 hyperscales. So you had the first thing I talked about with the 3 pairs of scales, and then I just showed you 3 pairs of scales for the inorganic part, and that makes up 3 parts of the inorganic hyperscale and 3 parts of the organic hyperscale, and that makes a pair of hyperscales, and those become a part of what I call a superscale. And ultimately, what it ends up looking at, like, it has this 3 of 2 of 3 of 2 of 3 of 2 structure. You can't visualize what I even mean by that. That's not important for now. I'm just trying to paint broad strokes. The reason why it has this 3 of 2 of 3 of 2 of 3 of 2 structure is because it's symmetrically asymmetrical with a 2 of 3 of 2 of 3 of 2 of 3 set of nested coordinate system. Basically for the atom, and then the stick figure molecules, and then amorphous medium. There's 3 nested coordinate systems, and the 2 part is the negative and positive, and that's of the 3 part, which is the 3 perpendicular orientations, and then there's 3 levels to it. And so that's why the structure of existence is divided how it's divided, is because it has to be symmetrically asymmetrical with these 3 nested coordinate systems. And that symmetry, the reason why the symmetry is important is that's what we use to avoid explanation, the need for further explanation, because the human mind only asks why when there's an asymmetry. So if we said, why 3 of 2, not 2 of 3, the answer would be, well, it is 3 of 2 and it is 2 of 3. I mean, it's 3 of 2 in this context and 2 of 3 in this context. So each idea is actually true and each idea is false. It just depends on the context. It's not excluding any ideas. And that idea is actually used, that strategy is used in theoretical science with the multiverse idea, except they want to say that everything is true. So that would mean that I've had sex with Neil deGrasse Tyson's mom in every single conceivable position. That's what I mean. And that gets a laugh, but that's actually a real thought experiment. That actually has to be true if you're taking what they're saying seriously. So I'm not describing that kind of a multiverse where there is no exclusion of possibilities, where everything is true, because they're excluding exclusion. But that's a side point. I don't want to get bogged down in that. So we have this really complicated symmetrical asymmetry. It's sort of like a really complicated yin and yang. And then I realized, like, this is over like 13 years, that this yin and yang is part of a more elaborate yin and yang. It's actually not entirely complete.